Hi everyone, I'm Jeff from Missouri Wind and Solar, and this is Wind Turbines for the Beginner. This will be part one of a series I'm doing on wind turbines for the beginners, the newbies. Just all of the basic stuff you need. If you've never owned a wind turbine and you want to buy one but don't know what to get, that's what this video is about. I'll be talking to you about some of the hype that's on the internet, eBay and other places, scams, myths, things like that. So there's a lot of wives' tales that are out there that have been told so long it's almost become so. So we're going to go through all of those myths and old wives' tale, and we'll dispel a lot of them. So we'll begin. You decide you want to buy a wind turbine, you've looked everywhere, and you've seen just literally thousands of them. Okay, so you don't know what to do, and you end up saying, oh, the heck with it, buying a solar panel. Well, wind turbines can run 24 hours a day, 7 days a week, whereas a solar panel will only charge a battery for maybe 8 hours a day. Now, if you've got wind, you can have 24-hour-a-day charging year-round. So, is it a good idea to have just solar without wind or wind without solar? It's a good idea to have both. They both work well together. Okay, this is an example of a 3-blade wind turbine. And this one is a 400 watt or a 300 watt wind turbine, 12 volt DC output. I know you guys have seen thousands of these on eBay and on the internet. You see them advertised all over, anywhere from 200 bucks on up. Give you an idea of what a 3-phase AC output wind turbine is. This is just a Delco type wind turbine, and 3 wires coming off from the stator core. Be 3 wires. This is 3-phase wild AC output, and you really can't use this. It has to go to a rectifier and be changed into DC output, something you can use. Now, there are grid tie inverters that you hook the 3-phase AC directly up to, but those already have built-in rectifiers. Okay, these are all rectifiers, and this is what you hook your 3-phase wild AC into, and you come out of it DC, positive and negative. These all do the same thing, different styles. Now, this is built in to the Delco Remy car alternator looking wind turbine. Now, this rectifier here is one that we use on a lot of wind turbines. Turn it around for you. Your 3-phase wire from the wind turbine connects to these 3 posts. Doesn't matter how you hook them up, and it comes out positive and negative. This you would hook to your battery bank, or you'd hook up to a charge controller. This is now usable power. This is also another rectifier. They come in all sizes, styles, and shapes, but you can spot them. They have 3 wires going in, 2 out, positive and negative. Which is more efficient, DC output or AC output? Okay, we'll go back to some of these books and DVDs that are on the internet and on eBay, saying that DC is the best output there is, and 3-phase AC output requires huge transformers and such, and they're the worst. Well, that is absolute garbage. It's hogwash, it's made up, because those people sell DC output wind turbines. Now, 3-phase AC output is definitely not only more efficient than DC output, but it's a lot cheaper. You can run a lot longer. For instance, a DC output wind turbine requires large cables to carry the power any distance at all. Very expensive cables. Usually a couple of dollars a foot, and you need a positive and negative from the wind turbine to get to your battery bank. 3-phase AC output, you can simply use an extension cord, 12-2 with a ground, 10-2 with a ground, and run it 100 feet, 200 feet, with literally no loss whatsoever. And it would go to a rectifier. All you would need on a 3-phase AC output wind turbine is an extension cord, 12-2 with a ground or 12-2 with ground. Okay, this is very simple. This is what comes off from all 3-phase AC output wind turbines. And of course they'll all be black. These colors are irrelevant. This will come in and has to be hooked to a rectifier. Once it's connected to the rectifier, doesn't matter how you hook it, you now have usable positive and negative DC power. From here, you would go to your battery bank, your charge control. Now, with DC output wind turbines, this is the size cable you would need. This is number 4 welding cable. You would need 2 of these, a positive and negative, from the wind turbine. You cannot use the wind turbine as a ground and simply hook the positive up the wind turbine. That's not how it works. So this stuff would be a couple bucks a foot. You're talking $3 or $4 per foot for 2 leads. You can run this stuff 50 foot maybe with no problem. You're not going to get a lot of loss, but you go any further than that and you're going to get major loss. So you're going to have to step up to a 1-gauge cable, and that stuff will cost you $2 plus a foot. So whereas the extension cord, this stuff, $1 a foot, even less. It'll run hundreds of feet with literally no loss whatsoever. You never ever use house wiring. That's hard stranded wire. Never use it on wind turbines, solar panels. You do not use hard single-stranded wire on DC output anywhere. And this is why. AC travels on the inside of the copper strand. DC travels on the outside of a copper strand. You need a lot of fine copper strands to carry DC current. This is what will happen. Say you have a solar panel and you use house wiring. You hook it from the solar panel to a voltage meter, and the panel, say, puts out 10 volts. Well, your meter is going to show 10 volts, but the panel is supposed to put out 5 amps. It's going to show a ½ an amp. Why? Because the amps are choked in the house wiring. You need several strands of copper wire or DC to carry the amperage. Okay, we're back. Different amounts of blades and sizes. This small turbine that I showed you that is very, very, very popular, and people really get pulled into buying this lot, need to know that this wind turbine takes a minimum of 12 mile per hour wind to get it started. That's 12 mile per hour. Now most of you just don't have 12 mile per hour all the time. So this wind turbine is really designed for sailboats, boat docks, that sort of thing. So this wind turbine, bad for people with low wind. Then we come to the multi-blade turbines. Why is 7 blades better than 3 blades? Well, this wind turbine will start basically at 7 miles per hour with no problem whatsoever. And if the wind dies down, just the mere weight of the blades, this will keep turning. It's kind of a flywheel effect. So this will keep on turning. It'll start much easier. Now, the 3 blades will build up higher RPMs and actually put out more power, but you'll need at least 12 mile per hour for that wind turbine that I showed you to start. Most of you just don't have that. So the less blades are better for higher speed, but for constant power production all the time, more blades is best. They will be running underneath 10 miles per hour and putting something into your battery bank rather than waiting for a 12 mile per hour wind up and putting some power into your bank. Now this one is a 7-blade unit, as you can see. And that's 11-blade unit, as you can see. Now that 11-blade is meant to start up in extreme low winds. And it won't reach the RPMs that a 7-blade will, but it will have more torque. More blades, more torque, but lower RPM. Less blades, higher RPMs, but less torque. Once they get under a load, when they really start charging a battery, 3 blades will slow down. 7, 9, 11 blades will keep on pushing the amps into your battery bank. Why are almost all wind turbine blades that you see odd numbers? There's a reason behind that. Now back to the books and the information, the DVDs that's sold on eBay. You'll see on the internet things that the manufacturers don't want you to know. Well, those same books, one of them especially, a DVD, seems to be selling pretty good. It says you must use 6 blades. You cannot have any more than 6 blades. If you do, you're getting ripped off. Well, it's kind of a joke because no real wind turbine manufacturer uses even number of blades for a reason. You notice all the big windmills on the windmill farms are all 3 blades. Well, they can get away with 3 blades because they're 100-foot blades. Now we're talking micro wind turbines. Each time this blade passes in front of the tower pipe, it will cause a disturbance directly across from it to the blade on top. And that will make the blades vibrate and shake. Secondly, even number of blades are almost impossible to get balanced. It is a bad idea. Now there was a 2-blade wind turbine out there on the market, but that 2-blade was made by Southwest Wind Power, and I think it was a Whisper, and it was a very expensive blade. And it was some real engineering to get that thing balanced. As you know, on aircraft, a lot of them are 2 blades. Well, those blades are thousands of dollars. You simply just can't do that in a small wind turbine industry. So, now types of blades. What type of blade do you want to get? There are several on the market. There are aluminum, plastics, even PVC. And I'll explain the difference in all these blade sets to you. The 2 wind turbines to the right are both 5-blade units, and the one all the way to the left is 11-blade unit. And the wind speed, believe it or not, is about 4 miles per hour. Now the one to the right is a 10-blade unit with a tiny tail. It doesn't want to spin. And there's a reason behind that. With the odd number of blades, when one blade is down at the bottom, 2 blades up at the top are offset. They are never directly across from each other. An odd number of blades, it's like a flywheel effect. When the one blade gets to the bottom, the weight of the blade close to the top is pushing down, and it kind of keeps it going. Even numbers, bad. Number 1 rule, if you're ever going to buy a wind turbine, do not buy a wind turbine with PVC blades whatsoever. Those blades are made for plumbing, and they do explode at 10 mile per hour, 15 mile per hour. They will not last out in the sun. They are not made to do that. And I get emails all the time from people that have got sucked into buying a PVC wind turbine blade. I don't care if they make them out of ABS plastic, PVC, or they paint them. They will explode. They are not meant for wind turbine blades whatsoever. They are dangerous. Okay, next we'll come to the aluminum blades and the composite blades. This is an aluminum blade and aluminum blade. You notice the large pitch on this aluminum blade? Well, the manufacturers tell you that the wind startup speed is extremely low. What they don't tell you is at 15 mile per hour, this blade will throw itself out of the wind and stall. It has a maximum RPM And I'm telling you, I've tested these type of blades, whether they're made out of plastic, PVC, or the aluminum blades with a huge pitch. I have tested those blades, and usually about 15 miles per hour, they are finished. They cannot get any more RPM out of them, and most wind turbines need to get up to 30 miles per hour for maximum output. And what a blade like this does is stalls out at 15 miles per hour, and you are finished making power. As you notice, the large pitch, say if the blade is turning in this direction, the wind is hitting the front side of this blade, and it acts just like a wall being pushed in the wind. So the worst blade on the market, large pitch, aluminum. Now, there's another aluminum blade down here, and these are good aluminum blades. Very little pitch, and as you can see, the wind will deflect around that blade quite easily. And of course the blade is turning this way. The best blades to get are ones with airfoil types. These are the best blades altogether. The blade tip looks like an airplane wing. Perfect pitch on them, high speed. They'll go quite a few thousand RPMs. These stall out. We're talking few hundred RPMs. These are done. This type of blade will give you the more pitch like this, very low startup, and this is going to give you a pretty high speed. But this speed will not reach what this speed will. To give you an idea, the one that had the slight pitch is over to the right, and the other one with the airfoil type is over to the left. These blades work fine. See, there's not, when they're pushing against the wind, there's hardly any resistance whatsoever. Now here's the other type of blade. As you can see, it's a huge pitch on these blades. And what happens, this side here is going into the wind, and it acts almost like a wall. These are the types that will throw themselves out of the wind and stall at, say, 15 miles per hour, 20 miles per hour, they're finished. You're done making power with these blades. But they have an extreme low startup speed. But all you're going to get is 15 miles per hour out of these things, and they're finished. Not worth spending your money on. Okay, now I've explained the wind turbine blades, the different types and stuff. So we'll go ahead and go to towers next, which you're going to need to put the wind turbine on. Okay, most wind turbines fit on 1.5 inch pipe, that's OD, or 1.5 inch pipe and 2-inch pipe. The actual dimensions of the 1.5 inch pipe is 1 7/8. Most of them fit on 1 7/8 pipe, or just commonly called 1.5 inch pipe. Now there is a tripod mount like this that you could use for mounting on your roof. Now you could build yourself a tower, like this one. That's up 65 feet. You could simply take a pipe, stick it in the ground, concrete it in up 20 feet if you want, or if you've got a garage or a pole barn, you can simply put it up through the roof like this, tie it into the rafters, and that's a 2-inch pipe. Now this is inside my pole barn, and there's the pipe coming through the roof. It ends right there on my beam, and I simply have a muffler clamp lag screwed to the 8x8 post there. And it's good to put rubber behind that pipe. Anywhere it's attached to wood, you need to really wrap the pipe with rubber, like an old car inner tube. Otherwise, the wind turbines will vibrate, they'll resonate through that wood. Okay, so let's hook up a DC output wind turbine. Now, the rectifier is built into this type. This is a Delco type, and the rectifier is built in. And what we need to do is get the positive cord and the negative hooked up to this. Now on the back of these PMAs, permanent magnet alternators, that's what they're really called, you'll see a red plastic post. This is where you're going to hook your positive cable to. The negative will just be hooked to the body of this. So this type of wind turbine, it doesn't have any slip rings. It's just called what's called a friction mount. So we got our positive on, slip it through the top. Get that tightened down good. And then our negative, you can see this here good. Our negative will just go to the body with a bolt. And then the wires will just go up to the top and down inside the tower. Okay, there we go. Both cables are attached and they'll run down through the tower and come out of the bottom. Now, on a three-phase AC output, it's the same for all of them. All of the permanent magnet alternators will have 3 wires out of the PMA. You just simply take an extension cord like this, connect the 3 wires to those 3 wires coming out of the PMA, and you're ready to go. There we go. This is what it's going to look like when you're done. And it just goes down through the top. Tighten the clamps down real good. And I leave plenty of slop in it, slack. I've got my wind turbine installed, got my wire brought into the building, and now I'm ready to hook my 3-phase wind turbine, 3-phase AC wind turbine, to a rectifier. Now here's the rectifier I'm using, and I have it mounted to a metal plate. Okay, I've got my 3-phase AC wires hooked up to the rectifier. The yellow, white, and black, it really doesn't matter. Just consider them all black. It does not matter how they go. Now, these rectifiers can get very hot. So I've mounted mine against a metal plate, and I'll show you behind it. The plate is standing off the wall. I just used a couple of nuts on the back side and a couple of screws, and that'll keep it safely off the wall and draw the heat away from the rectifier. Now that we've got that hooked up, we have a charge controller. We're going to need a charge controller. So I have one here. And this is a basic charge controller. It'll handle up to 10,000 watts, 440 amps of input, wind and or solar, or at the same time. Okay, we have a 12-volt wind turbine, and it's going to be used for charging 12-volt batteries. So everything has to be 12 volt. The charge controller has to be 12 volt. The inverter will have to be 12 volt. The battery bank 12 volt. Everything 12 volt. Now the reason I need a charge controller is if I don't, the wind turbine will just simply keep spinning, overcharge the batteries, and burn them up. So they all need a charge controllers. Wind and solar, both do. This is a basic charge controller. Very simple. It works really great. Now, our battery bank. These are 4 Trojan 6-volt batteries. Very popular. A lot of people use them. You should just use a 12-volt single car battery. And all of it would just simply be hooked up to the positive and negative. But I'm going to use 2 6-volt Trojan batteries, and I've got them tied together to turn them into 12 volt. Okay, here you go. This is the positive, and this is the negative. These are 2 6-volt batteries. I need a 12-volt battery, so I'm going to tie these together in a series, and that's what it's called, to make a 12-volt battery. So connect the positive to the negative. Now, at this end, just pretend we have one 12-volt battery here now. You'll come off the negative and positive to your inverter and to your charge controller. Okay, first we're going to get that charge controller hooked up to the battery bank, and I've already did that. Now in this particular charge controller you have a black and a red sense wire. That goes to the charge controller itself. I've already hooked it up, and you see the light is flashing 3 times. It means the batteries are a little bit low. When the batteries are full, that light will stay solid green. And when they go a little bit beyond full, it's going to disconnect the incoming power. Okay, there's my 2 sense wires. Remember, I took these two 6-volt Trojan batteries, and these are wet cell batteries, and I turned them into a 12-volt battery by wiring them in series. Anyway, you can see the positive and the negative. I hooked the negative to the negative and the positive to the positive. This 12-volt controller is working just fine, perfectly. Now for this particular controller, there's 2 ways to wire this. One with a dump load and one without a dump load. And this would really be for solar, not using a dump load. The dump load is actually for a wind turbine, not solar panels. So for now, we're just going to hook the wind turbine up, so when the battery is full, it will disconnect. So, we've successfully hooked up the charge controller. The positive from the rectifier, this is DC output now, if you remember. The positive will go through this relay, out of the relay, down to the positive on the battery bank. The negative off the rectifier goes straight to the battery bank. We're all done, it's hooked up, everything is working. And this is in disconnect mode. We'll pretend that the electricity from the wind turbine is coming in, the battery is full, push the test light, boom. It's disconnected the incoming power. And it will stay disconnected for so many seconds. Release, it will sense the battery and do it over and over again. There you go, that's out. Now, you've got your batteries hooked up. You want to get power out of them, how do you do it? Let me show you. Okay, here we go. I just use whatever the manufacturer tells you to use, whatever size cable they recommend. And this is number 4 for this. So I've got my positive and my negative, good tight connections, hooked to the positive on the battery bank and the negative right there. And there you've done, you've completed it. You've now successfully installed your first wind turbine to a 12-volt battery bank. Now let's see what happens. Power's on, it's up and working. Okay, the inverter's on, it's 800 watt, 12 volt. What can you run on it? Well, it's a nice little grinder. Well, let's try a circular saw. You can run quite a bit off this little 800 watt. Now, this system can be expanded on anytime you want. You can add more batteries, you can add more wind turbines, and keep building up.